Hello everyone and welcome to today's webinar on infrastructure as code. Good morning, good afternoon to the folks joining from different parts of the globe. My name is Noor Basha, Marketing Director at Winwire Technologies, and I'll be your moderator for today's webinar. As you know, today's topic for the session is how to get started with infrastructure as a code. And where in the next 30 minutes, we will learn how you can automate your infrastructure deployments along with a quick demo. Before we start, let me highlight a few housekeeping items. During the webinar, please feel free to post questions and we'll try to answer as many as we can at the end. We are recording this session and we'll share the presentation as well as the recording in next 24 to 48 hours. So with this, let me introduce you to today's session speaker, my colleague Sai Gunaranjan. He's the infrastructure architecture at Winwire Technologies and brings over 12 years of IT industry experience and specifically working on the Azure-based solutions at Winwire Technologies. He specializes in designing, managing, and deploying solutions across like cloud, on-prem, as well as hybrid, leveraging Microsoft Azure. So with this, let me hand it over to Sai so that he can quickly help us get started on the session. Sai, over to you.
Thank you, Noor. Hello, everyone, and welcome to this session. In this session, as Noor mentioned, we'll quickly try to talk about what is infrastructure as code, the benefits about it, why we should be using it, and what benefits that IT pros actually leverage from infrastructure as code. And then also I'll be showing a quick demo and also kind of giving us tips and tricks of how to get started with infrastructure as code, primarily using Terraform or any other tools that you're comfortable with. So moving on to the first slide. So first of all, what is infrastructure as code? That's now so there's a lot of discussion about what is it, how to go about deploying it, how to go about using it in production environments or in day-to-day operations as well. It's nothing but the process of managing and provisioning your infrastructure services, components of an application using configuration files. Basically, all of your infrastructure components such as networks, virtual machines, load balancers, the connection topologies, everything that typically an IT admin or IT pro would actually use PowerShell or use the portal or use command or command prompts to go ahead and manage, build, and deploy those components can now all be defined and deployed using a single configuration file. Either using tools and products such as Terraform, ARM templates, or even PowerShell itself, to actually deploy and configure a couple of components. And one of the cool things about this infrastructure as code is that it can be used across platforms. So most of these tools actually support a cross-platform and even on-prem VMware-based architectures. They actually kind of help IT pros deploy services and components across various environments. So if you have a multi-cloud or a private data center, you actually can use the same tool to actually configure Azure, AWS, and even your on-prem virtualized environments. These configuration files and these settings actually integrate easily into your source control, such as Azure DevOps, and then actually go in line with the release pipelines. And this basically enables an IT pro admin and an IT pro to actually have a software-defined data center rather than having to actually go to various portals and various management consoles to manage the various configurations of every component or every device per se. So what benefits do we get primarily out of this? First thing is fast execution. Everything is one big configuration file, as long as the configuration file is properly written and it's defined correctly and the variables, everything have been defined correctly. It's just one click or one command, and then the entire environment gets deployed. It's fully error-free as long as the configurations the configuration files are correct and there's no mismatch over there. There are no errors. Irrespective of how many times you deploy the same environment, every time it remains constant. It actually remains the same without having any problems. If you have to do a manual way of doing it, it's very much error prone. There might be a wrong click or a wrong command being set up or a wrong checkbox being ticked. And every time there's a new application or a new environment being built up, there's a lot of inconsistencies between the primary environment and secondary environment, or the dev versus test and the UAT and so forth. It's extensible across, as I mentioned earlier, it's actually extensible across every cloud platform. So irrespective whether you're using Azure, AWS, GCP, or even on-prem VMware kind of services, it actually spans across all of them. So using one tool, you actually can manage and configure infrastructure services across various platforms, and it's fully extensible with every other provider as well. One of the key things of infrastructure as a service is it's being idempotent. It actually evolved to solve a biggest problem with infrastructure. Is every time there's a release pipeline going on, there's an environmental drift. It's causing a big problem wherein the dev versus test versus UAT, and then the production, there's a huge difference in how the infrastructure is configured for all of these environments. To fix that, and to fix one of those problems, is where the code-based configurations came in, so that every environment has a consistent and has an error-free deployment of infrastructure services, and application can be deployed on top of it. The other cool thing about this, using this methodology is the infrastructure services can be bundled in with the application pipelines as well, and then there can be a sequencing setup wherein the infrastructure gets deployed and then application gets deployed on top of it, completely using DevOps pipelines and so on. So it's actually a very effective way of managing, deploying, and setting up the environments for application and business users as well. And that's where it becomes more cost effective, because there is less time troubleshooting issues. There's less time, fixing problems on environments that are being built on a per minute basis, wherein that every time you have a consistent environment when you're kind of building it up. And that's the reason why it's very much cost effective as well. So how to get started with this? Few things that we need to kind of take a note over here is that we can use any IDE that is available. You can have Visual Studio Code, or even Azure PowerShell, or even Azure Shell that's available directly within the browser itself. And the tools that are actually available are ARM templates, which are primarily native to Azure, and it works basically on Microsoft platform. Terraform, which is a third-party service, it actually integrates into various providers as well, irrespective of whether it's Azure, AWS, or even VMware. You also can use PowerShell and Bash, which are again kind of going back to Azure, when you actually have an option to configure your resources using PowerShell and Bash. All of these tools and methods that have their own pros and cons. Terraform being it's actually cross-platform compatible, but then templates and PowerShell are primarily kind of very relevant to Azure and Microsoft-based technologies. So with this, I'll quickly move on to a demo, and then I'll kind of come back to how to implement the infrastructure as code as well. So first thing is, what we'll do is we'll actually identify something to automate, which is maybe even something very simple, setting up like a virtual network, setting up like a subnet, and then from there on, we can actually do some trial and error, try to see how it actually works, how it actually suits our environment, and then from there, fine tune the templates, fine tune the configuration files. And then from there on, kind of use it for every other environment that we're kind of building out. So with this, for this demo, I'll be using Terraform for our infrastructure deployments. I'll talk about from first. How to the downloading of it, the configuration of Terraform, and then also show us a very simple Terraform configuration file that I actually have, a TF file that I have, and then we kind of go through the whole cycle of applying the configuration file, making some changes to it, checking some errors, and also clearing up the entire environment, basically just deleting everything we just created. So with this, I'll switch over to my Visual Studio Code. So first things first, if you don't have Terraform already installed, I recommend going to the Terraform downloads page and then getting the Windows version or any other version that you're comfortable with. It's basically a single executable file. You download this, and then once you download it, you actually unzip it to a C Terraform directory or any other directory that you're comfortable in. So once you have the unzipped version, what we got to do is we'll actually go to the path variables. So what we got to do is in the path variable, we actually need to define the Terraform environment. So they can see I actually have both Terraform environments defined. This is the default location. This is the location that I have actually been using. So once we have this and the executable is actually placed over here, what we got to do is we'll actually from there on that's it. Basically that's how we install Terraform. There is nothing else to do. There's no other configuration that needs to be completed to actually install Terraform. Once you have this the executable file copied and put it on into the respective folder, you can either open up a command prompt or PowerShell or even Visual Studio or even the Visual Studio Code. I'm going to be using Visual Studio Code in our case. And what I'm going to be doing is I'm actually going to just initialize the environment. And for that, we need to do is it's a simple command. It's called Terraform init. And this actually downloads latest providers. So in my case, I'm actually using an Azure RM provider. And I have the latest version of Terraform version 1.28 actually being used. The provider version of 1.28 being used. And once I do init Terraform init, it actually gets the respective providers plugins and then keeps a copy of it on within your machine. After this, what we actually open up the workspace that we actually have our Terraform configuration files in. In my case, I actually have the file open. This is the main.tf. Here you can see that I've actually used a provider Azure RM, and then the version is actually defined over here. And I also have the tenant and subscription ID defined over here. If you're not comfortable, putting in your credentials every time you want to run this, and also we can't use it for production purposes. We also can use the service principal option available, wherein we actually define the service principal, the passphrase, and the key and everything within the Terraform variables file, and then encrypt it, and then you can call those variables over here. And then apart from that, so in this Terraform file, I am actually doing something very simple. We're going to create a resource group called demo. And then we're going to have a virtual network, and then within the virtual network we'll have a few subnets, and then we also have a storage account that's actually going to be created within this resource group. What you can see is I have two configuration files over here. One is at main.tf, which actually contains all the resources that are going to be deployed, and I have a lot of variables that are being called. So the what would basically we do is, we have a file called terraform.tf vars where I have all the variables and all the definitions actually set up, and I'm actually going to call all of those in the main.tf file. And as you can see, I've actually declared the resource location, the RG name, prefix, address space, and so on. I also have 3 subnets being defined and also have an NSD group being defined. And each of these variables I'm actually going to call within the resource provider, within the resource I'm actually creating. So initially, we actually have a resource that's actually called Azure resource group, which is primarily the first thing that we should be creating. And we have the name and the location being defined. Within that resource group, I'm actually defining the virtual network. The virtual network location again is getting picked up from the resource group, and then the resource group name and also the address space. Address space is already defined in the TFVARs, the TFVARs variable file. So I'm actually getting information from here, and then so on. We have subnet 01 being created. Again, these are all for the demo, so it's not following the naming conventions and stuff. Within production, these should be more appropriately named, and we follow the better naming conventions. That time we'll have subnet 01, the subnet 01 address prefix as well, the resource group name, the virtual network it's actually going to tie to, and so on. The interesting thing also is something called depends on parameter that's available in Terraform, wherein if you want a resource to be created only after it actually, solely after the previous resource has been created, or if you have a dependency, you actually can kind of define that, so that so in this case, unless the subnet 01 is created, subnet 02 is not going to get created. It's actually not going to even kind of even go through the file, because you have a dependency that's actually defined over here. Similarly, also in the subnet 03, I have a depends on kind of setup, which is actually going to go to 02. And then finally, we also have the Azure storage account that's going to get created with the name and everything that's actually defined within the TFRs file. So what we'll do, and the last one is also the NSG group, which is actually going to get associated to the virtual network that we created at the top. So what we'll do is, now that we have actually got the initiation completed, I'll do a quick Terraform. So if you want to see what's actually going to get deployed and what's exactly going to happen, so what we'll do is we'll actually do Terraform plan, and this will give us this will give us a picture of what's exactly going to happen within the Terraform configuration file that we actually have set up over here. So this is going to take us through it's going to let us know that there's going to be a storage account, there's going to be a resource group being created, a network security group, a resource group, a storage account, and then it's going to have subnets, and all the three subnets that we actually defined in the configuration file. And the next thing that we can also do is we also can do something called Terraform graph. This actually shows us a complete hierarchical picture of all the resources that are actually going to get deployed and its association with the various resources. It's actually a cool feature to see, what where we have, how the entire thing is going to get deployed, and the various nodes that are actually going to get fixed within the deployment that we're actually doing. Now, to actually do the actual deployment, sorry, it's actually Terraform apply. So now this actually again goes through the workspace where we have the main.tf file, and it's quickly going to see all the resources that we have actually planned to deploy, and it's actually going to let us know that we plan to add 7, 0 change, and 0 to destroy in this case. So what I need to do, I need to just go ahead and press a yes as a confirmation, and once I go ahead and do this, you can start to see it create all of these components within the resource group that I've set up. We also get a complete verbose picture of what's happening, how many seconds it's actually taking, how much time it's actually going to get, how much time it actually takes to create every resource. And it's a lot faster than going to the portal and then, doing it from there. So all we need to do is, have this configuration file ready, and then everything just falls completely in place after that. Also, there's a very good error catch facility as well. I'll show you over here, wherein it in case you have a variable defined incorrectly, or if you have a problem with the naming convention that you're actually using, it will throw an error, like how a portal actually throws an error. And in this case, you can see that the storage account is actually errored out, saying that this is not a valid name, and very similar to what we get to see. And the reason why this is not a valid name is because storage accounts in Azure they don't like the uppercase characters. So we actually need to change this to actually do a lowercase character. So what I'll do is I'll go back over here. I just change my variable. Save this file and come back over here. And all I need to do now is actually again go ahead and just do an apply. And when I do this, it's not going to change anything else. It's actually just going to see all the resources that actually were missed in the original deployment. And it's just going to deploy that one. So all the virtual network, everything will remain untouched. So they'll just refresh it and ensure that it's the same as the definition that's already been set up. And then it's going to say we're only going to add 1 because everything that's already updated. And then we go ahead and do an S. And once this happens, you get to see that it's going to create the storage account as well. While that's happening, I'll actually go to the portal. and we'll take a look at the resource group that's being deployed. You can see that there's webinar demo that's got created right away, and within a few moments you'll actually see the storage account as well coming up over here. So it's still creating the storage account and it says completed. Come back over here and we get to see that the storage account also exists over here. All the settings, all the configurations that we set up in the variable file is also shown up over here. So we have subnets 1, 2, 3. We have the definition all been set up. We have the address space that's been set up over here. We also have the address space that's actually been set up in in the configuration file as well. And we have the storage account, the same name, its properties, everything set up over here. So we've set up as a GRS, and we have whatever is defined over here is also set up with the storage account as well. Other thing also we can do is so from here also we can do a refresh if required. So if there's any changes that actually has happened within the resources or within the configuration files itself, it will refresh them. It will ensure that everything is actually in line with the definitions itself. This way, going back to what we spoke about it being idempotent, every time, so even in case I go ahead and I come here, I maybe make a change to something, I go ahead and suggest I delete this NSG, for example, as one of the administrative tasks, and okay, it's associated with so if I disassociate this and I delete so I remove this, right? So if I go back over here, if I just do apply right now, what it's actually going to do is it's actually going to verify any changes that have actually happened within the environment from when this the previous apply actually has run, and it's actually just going to say, one is missing, and we're just going to go ahead and create that, and 3 to change, because you have to actually kind of associate the subnets back into the NSG, and 1 to add, that is because the NSG is deleted anymore. So if I just go ahead and say yes, it ensures that. So every time there's a change in the environment, Terraform kind of tools actually help you and kind of go back to original configuration, or if it is a proper change that you actually want to propagate against every other environment within your within the IT organization, we can use this kind of tools to ensure that all the environments are consistent and the proper change process is followed. If someone had to go ahead and change something within the portal not using Terraform or not using the infrastructure as code methodology, the next time you do an apply, or the next time you actually refresh the configuration, it's just going to update everything else, and it's just going to come back to what it used to be originally, or what it was intended to be originally. Now the last thing is to go ahead and clean up this environment. Now that all the testing is completed, and then if you want to delete everything, we either can go to the portal and then click on delete and then remove everything. In this case, we have very few resources, so it's easy to do. But if you have a large deployment that's actually been set up, and then if you want to go ahead and do this one by one, it's actually not going to happen. It's going to be a very time-taking kind of process. So what we do is we just use the Terraform destroy command, and this will actually clean up the entire environment. It'll let us know what it's actually going to do, and we just say yes. It's going to destroy. So it's, as you said, it's going to destroy 7 items. You say yes, and it's just going to delete everything. It's as simple as it. You don't have to go to the portal. You don't have to go and do anything within the GUI itself. So if I just refresh this page right now, we get to see that this is right now being deleted. And within a few minutes, you'll actually see the entire thing go off. With this, I would want to. I'm done with the quick demo. I just want to leave a few questions to see if there's any, a few minutes to leave, see if there's any questions. Just coming back to the slides that we have.
Thanks, Sai. Thanks for the quick session as well as the demo. Certainly, there are a couple of questions. The first is from Mark, where he asks, in what scenarios one would use ARM templates versus Terraform?
Sure. Sure, Mark. So actually, this is this is a very debatable topic. This ARM templates has been available, has been a proprietary or a native to Azure, and it actually has all the providers and all the features and everything already fully available within ARM templates. And we actually can deploy everything using ARM templates as well. And Terraform is fairly new, and it's the availability for it on Azure is maybe not to the fullest as ARM templates. But then Terraform actually gives us an option or a feature to actually manage multiple ARM templates as well. So using Terraform configuration files, you actually can deploy ARM templates as well. And it kind of provides us like a higher level tool that actually integrates with various other services and various other the cloud platforms as well. Other thing also I've seen is Terraform, things like maintaining idempotency or environmental drift. I think Terraform is more, proper in doing that because it actually can go back to original state. But then ARM templates, if you deploy the same template again, it will start kind of throwing errors at times, saying that the other environment or the other resources are already configured, and because of which you might actually have errors in the overall deployment. So yeah, so if it is specific to Azure and if you're already using ARM templates, you can definitely do it. But then using Terraform, you also can call ARM templates. So that's I would definitely want to use Terraform, for everything.
Thanks, Sai. So the other question is, what is the difference between variables.tf and Terraform.tf variables?
Sure. So yeah, this is also I think like a very interesting discussion. So both of these variables.tf and the Terraform tf vars files, both of these actually can be used to declare and define variables. But then variables.tf is something where you actually can declare, define, and assign default values to variables across Terraform. And then the tf vars is very specific to a specific module. So in deployments where you have multiple module-based deployment using Terraform, you can actually have variables.tf against all modules, wherein you have all the all the variables defined there with the default value, with the description and everything. And then Terraform.tf vars is specific to every module which has values for that, like how we just saw. So I'm actually using Terraform.tf vars. It's basically a key value pair. We have a variable, we have a value, and that gets referenced to in the main.tf file. And another thing also using tf vars is that when you do a Terraform apply, we actually can specify multiple tf vars files as where we have the variables. And if you're not following the standard naming convention of Terraform.tf vars, you also can specify Terraform apply and then hyphen vars and the specific file name that you're actually using. Yeah, so in short, variables.tf is a more higher level against every module, and then tf vars is very specific to every module that you're using within your deployments.
Sai. So I know we got a couple of more minutes. So one last question, Sai, is there is some new updates of Terraform. Is there anything specific that is there in the new version that is not there in the older version? Can you just
Sure. So I think the newer version has more providers and more has more resources available for Azure specifically. But then there is a little syntax change as well. The earlier version was Terraform 11, and then I think recently there's been Terraform 12, sorry, not 11. So it was actually 0.11 and then 0.12 that's actually got released. I actually had to change mine to 0.12, wherein a lot of the syntax and stuff has actually changed. But Terraform has actually made it very easy. So once we have 0.12 installed, you actually can update all your configuration files and everything using a simple upgrade command. And then, if there's anything that's actually having an error or if there's any depreciated commands, it actually highlights that and actually even goes and changes it to reflect the newer providers and the newer resources as well. And also, additionally, from 0.12 onwards, the provider version 1.27 is only available. So if you're using the older, if you're using the older providers such as 1.22, 1.23, and so on, they don't work with 0.12 Terraform version anymore. So that's also another change that actually happened.
Great. Thanks. I know we are out of time now. So again, thanks everyone for taking time to join this webinar. Before we wrap it up, I would like to quickly highlight about our next webinar, which is on June 13th at the same time, and this is on modern collaboration using Microsoft bot framework, where we had presented this session at the recent SharePoint conference 2019 in Las Vegas, and we had a very good attendance, and we just thought of sharing the same learnings with you all. So looking forward you joining us to our next webinar. Thanks everyone. Have a good day. Thanks Sai for taking time to give this insights on infra as a code. Have a good day.
Thank you, everyone. Thank you, Noor.